What a beautiful day today. And last we talked about how much energy the sun delivers to our planet every day. And we also learned that energy cannot be destroyed. So I want to ask you a question. Last class I asked you to think about what happens to all of the energy that's been hitting this valley, that's been hitting California, the United States. What's been happening to all that energy? If it can't be destroyed, well, how much energy has the Earth been given for the past millions and millions of years? What happened to all that energy? Well, I'd like to start out with showing you that I have a basic tumbleweed here. Just a basic tumbleweed that's probably from last season. And I'm going to break it up. And I'm not doing a chemical change, I'm doing a physical change. I'm physically changing it without manipulating the molecules. And I'm going to put it here in my little tiny smoker right here. And then I've taken some other wood, and I'm going to put it here and layer it. And what I'm doing, this tree is from about 6 years ago. And so you can think about that the light that hit our planet 6 years ago and landed right here on this hill. This tree took advantage of the sunlight, rearranged the carbon molecules and the oxygen molecules, and created sugar, which created this cellulose, which is wood. And what I'm going to do, once it gets a little lighter or darker tonight, is I'm going to show you a process that you've probably heard of before, where I'm going to convert this wood using a chemical change, and I'm going to convert it, and I'm going to bring back the energy that hit our planet so many weeks and years ago. And so I'll just pause it right here, and we'll wait until it gets a little lighter, and then we'll bring the sun out. The sun that hit the earth weeks and years ago. Hear those birds saying goodnight for the evening? Well, the sun is going down. Now, I have some wood here, but before I get started with my experiment, I want to show you something that I learned in the Boy Scouts. It's called safety. Never ever have an experiment that you can't have a safety precaution. Right now, I have water. Beautiful H2O. Now, before I get started with my experiment, I just want to say, water is the most amazing substance in the universe. Think about it. It is the only substance that when it becomes a solid, it loses its density. I mean, think if I had a big vat of iron ore and I took a solid iron block and threw it in, the solid block would sink to the bottom. Every solid is denser than its liquid counterpart, except for water. When water becomes a solid, it floats. Now, if that didn't happen, the whole bottoms of the oceans would be filled with miles and miles of ice. It's amazing. Our planet is just the most amazing system that takes advantage of everything, even the oddity that water does when it freezes and floating. But the other thing that's pretty amazing about water is the component of water is hydrogen and oxygen, H2O. Now, the thing that's really amazing about that is just think about what hydrogen is. Not only is it the base for beginning stars, where you're talking about pure energy as it fuses into helium, but also if I were to have some hydrogen gas, it's one of the most flammable gases on the planet. I mean, hydrogen gas is considered an extremely explosive gas. And we know that water, you can't have fire without oxygen, right? And water has oxygen in it. H2O has it has hydrogen, which is the most flammable gas, and then it has oxygen, the element that's needed in order for fire to take place. If you didn't have oxygen, You could have a whole swimming pool full of gasoline and it wouldn't catch on fire because there would be no oxygen to combust it. But here's the amazing thing. You put those two things together, the gas, the element that is the most flammable, and the element that is necessary for fire, and you put them together, and you get the universal solvent, the base of all living things on our planet, and the thing that puts out fire. And so I have this because, as you can probably expect at my scientific experiment, my chemical reaction is I'm going to take the energy that's been locked up inside of this wood for probably 9 or 10 years. I'll say 10 years because many of you are 10 years old, so I like to think that the light that hit the planet when this tree was around, it is really light stored energy from before you were born or around the time you were born. And even though the sun is setting and it's soon going to be nighttime, you're just seeing the horizon, the basic sunlight just kind of reflecting off of our atmosphere over Redlands there. But I'm going to do something now is I'm going to release some heat and light from the sun that hit my property so many years ago. Oh boy, I can already feel its warmth. So when I broke these up, I told you that it was a physical change because I took the wood and I took from big piece to small. That's a physical change. But now I'm having a chemical change. The molecules are actually changing. And what's being released, you can see with the smoke here, what's being released is carbon monoxide, which is very, very deadly, dangerous gas. That's why you never, ever, ever want to have a fire inside of a closed place, because even though you can't smell it or see it, if there's carbon monoxide, it will go into your own blood system and steal an oxygen molecule, and it can cause serious it'll kill you. So don't you ever have a fire indoors. But look at this heat right here. This warmth is basically stored sunlight from 10 years ago. And it's given me this beautiful warmth and light. Even though the sun is down, I'm exposing, or this chemical reaction is exposing the sun's energy that was delivered so many years ago. Now, how long? Was it just one afternoon? No. This tree was alive for many years. So the sunlight that's been stored up in this tree was the sun hitting it day after day after day after day for several years. You know, if you take a tree and you cut it, you can see the rings in it. Each layer of those rings represents a year. So we're talking about a lot of energy right here. Now, it's going pretty strong right here. And as you can see, I didn't really even need to put any paper or anything. This is why you never want to have a fire without water around, or forest fires or brush fires are so deadly because one little spark, as you can see, this thing ignited, and just like that. So you never ever want to play with fire. I'm in a really enclosed area right here, or open area with nothing around that can catch on fire, and I've got my wood here. But anyway, what's being released not only is carbon monoxide, but is the carbon and some potassium in the form of ashes. And so when this is done burning out and all the ashes are there at the bottom, I will take those ashes, called potash, and I'll sprinkle them around some of my trees, especially my fruit trees, and it is very good for their molecular structure on helping building that sugar molecule. Well, you can see my sunlight is fading, and now we just get to sit by the fire and watch the beautiful sunset over the valley. We sure do live in a beautiful place,